This is experiment number 5. What is the name of experiment? RC phase shift oscillator. In the first 4 experiment, we studied amplifier. What was the function of amplifier? To increase the strength of weak signal. Today, the experiment which we are performing, that is RC phase shift oscillator. What is the meaning of oscillator? Oscillator is a circuit which converts DC signal into AC signal. In the first semester, we studied rectifier. What rectifier does? AC signal to pulsating DC. But here oscillator is converting DC signal into whenever AC we want and it is not available, but we are having DC supply. This circuit converts that DC into AC signal. So the first experiment in the oscillator, that is RC phase shift oscillator. How to perform the experiment? Here you have to connect the VCC supply. In the first 4 experiment, we used to connect the signal generator output to the circuit as an input. But in this experiment, you are connecting only power supply as a VCC. There is no any other instrument is used to connect the input signal. Previously, we used to connect signal generator output, but in this experiment, we are not connecting signal generator output. Here, we are using only DC power supply. Connect DC power supply here, and if you take the output here, you will get AC signal as out. No need to change any supply value, no need to change any frequency. Connect VCC and get the output signal as a AC. Now, why the name RC phase shift? If you check this connection, first R, first C, second R, second C, and third R and third C. There are total 3 RC connections. Each RC network gives 60 degree phase shift. Each RC network gives 60 degree. So 60 plus 60 plus 60, total phase shift is 180 degree. And additional phase shift transistor is giving 180 degree. Now what is the reason that we want this phase shift? Carefully remember, in amplifier we used to connect negative feedback, but in oscillator we are using positive feedback, in which the phase shift around the loop is 360 degree. That 360 degree, how we are getting? Each RC network is giving 60 degree each into 3, that is 180, and additional 180 degree phase shift is provided by transistor. So 180 plus 180, what is the phase shift? 360. That gives, in oscillator we are using positive feedback. I told you only one advantage is there in positive feedback. What was that? It increases gain, and that is required in oscillator circuitry. That's why these 3 RC network with transistor gives 0 degree or 360 degree phase shift. Right? This is the phase shift network, and here this part is an amplifier, simple amplifier. So with RC phase shift network and amplifier, we are getting DC power which is connected as an input. We are converting it into AC. So once again I repeat, oscillator is a circuit which converts DC to AC signal. So how to perform? Now connect these 2 wires here. Right? This is the DC connection. Here it is written how much voltage you have to connect. It is 8 volt. So before switching or before connection, switch on the power supply. Keep it on 8. Make 8 volt. Now increase from this, correct. Your DC is 8 volt. That 8 volt first you set and then you connect the supply. Correct. Now connect these wires to the output. Okay. Now we'll check here. Now see here. What is your input signal? DC. Without any signal generator input, directly the DC power is converted into AC. This is the function of oscillator. Now here what you have to do? You have to just measure the frequency of the signal, because this is frequency generator circuit. Now already we discussed how to measure frequency. Still, if you want to check what is the frequency, first keep it on DC, ground. When it is ground, set your axis exactly on x-axis, that is trace, and now you keep it on AC. You will get from this line above this axis as well as below the axis. Equally it will be divided. Now if you want to measure what is the one cycle distance, you set any one point. Now see here carefully. I have set this point exactly on the crossing point and count the total distance. 1, 2, 3 and 4. So this is 4. Now to find out the time period, which switch you have to take here? Time per division. This is 4, and now see the position of time per division. It is 0.5 millisecond. So 4 into 0.5 millisecond. If you multiply this, you will get the time period, and then take the ratio of that, you will get the frequency. This is the first table which you have to complete in the experiment. You have to just find out the frequency. So immediately do it. 4 into 0.5 millisecond. Huh?
2 into 10 to power minus 3.
2 millisecond. Make x inverse. Answer.
0.002.